Hello guys, now today we are going to look at the log form of inverse hyperbolic functions. Now from the fact that the hyperbolic functions can be expressed in their exponential form, then they can also be written in their log form. So let's say we express sine hyperbolic inverse of x in its log form. So let sine hyperbolic inverse of x be equal to some y. Then bringing the sine hyperbolic to the other side of the equation, we have x is equal to sine hyperbolic of y. Then we write this in its exponential form. So this will give us x is equal to exponential y minus exponential minus y, all this divided by 2. Okay, if we multiply 2 on both sides, we have 2x is equal to exponential y minus, I can write this as 1 over exponential y. Then multiply this exponential y throughout the equation so that we have 2x exponential y is equal to exponential 2y minus 1. Now this forms a quadratic equation. So I would like to rearrange it so that we can be able to see. So we have exponential 2y, bring 2x exponential y to the other side of the equation. So we'll have minus 2x exponential y minus 1 is equal to 0. So if we let the exponential y, let's say, be equal to some p, we will have p squared minus 2xp minus 1 is equal to 0. So we can be able to see this is in the form of a general quadratic equation, ax squared plus bx plus c is equal to 0, where our a is equal to 1 and our b, that is the coefficient of x, and in our case here our x is corresponding to p, is equal to minus 2x, and our c is equal to minus 1. So using the quadratic formula, which says that if we are evaluating the value for x, we get minus b plus minus the square root of x squared minus 4ac, all this divided by 2a. Okay, all this divided by 2a. So this will give our value of p will be equal to minus b, and our minus b in this case is minus 2x plus minus the square root of b squared. Sorry, this is supposed to be b squared. The square root of b squared. So our b squared in this case is minus 2x squared minus 4 times a. Our a is 1 times c, and our c is minus 1. All this is divided by 2 times a, 2 times 1. So what's the value of our p? Our p is equal to 2x plus minus, this will give the square root of 4x squared minus will give us a plus 4, all this divided by 2. Now we can factor out the 4 inside the square root sign so that we have, and also like distribute this 2 on both sides so that we have our p is equal to 2x over 2 plus minus the square root of 4 into x squared plus 1, all this divided by 2. So evaluating the square root of 4 and the square root of this side, we will have our p is equal to x plus minus the square root of 4 and the square root of x squared plus 1, all this divided by 2. Now the square root of 4 is 2, so this and this will go. But remember, what was our value of p? Our value of p was exponential y. So bringing this back, this is exponential y. In order for us to get the value of y, which is basically sine hyperbolic inverse of x, and we needed to write it in the log form, we introduce logs to both sides of the equation. So we will have ln on this side and ln on this other side. Now, using the power law of logarithms, we can write this as y ln e. And what is ln e? Ln e is 1. So this is equal to ln x plus minus the square root of x squared plus 1. So this is 1, so it's the same as not including it there. So our y is equal to ln x plus minus the square root of x squared plus 1. And basically, that is the log form of sine hyperbolic inverse. That is the log form of sine hyperbolic inverse of x. Okay, in a similar manner, we can get the cos hyperbolic inverse of x. So cos inverse of x. Let this, so this is our number 2, let this be equal to some y. So bringing cos to the other side of the equation, we'll have x is equal to cos y. Then write this in its exponential form. So the procedure is more or less the same. Plus exponential minus y, all this divided by 2, then cross multiplying, we have 2x is equal to exponential y plus 1 over exponential y. So multiplying exponential y throughout the equation, we have 2x exponential y is equal to exponential 2y plus 1. So this forms a quadratic equation. Rearranging it, we'll have exponential 2y minus 2x exponential y plus 1 is equal to 0. Then let's replace exponential y with p. So this forms a quadratic equation with our values over. So let's first of all write it as let exponential y be equal to some p. So the first term there will give us p squared minus 2xp plus 1 is equal to 0. So if you write a general quadratic equation besides it here, so that we're able to identify the coefficients. So the coefficients here, we have 1, the coefficients b here, the coefficient of p will be minus 2x, and c is equal to 1. So using the quadratic formula to solve, our p will be equal to minus b plus minus the square root of b squared, so that is minus 2x squared, minus 4 times a times c. All this divided by 2 times 1. So what's the value of our p? Simplifying this, we have 2x plus minus. This is the square root of 4x squared minus 4. All this divided by 2, divide by 2. So inside the square root sign here, we can factor out 4. So we have our p being equal to this. That can cancel out. We have x plus minus 4 into x squared minus 1, the square root of that, all this divided by 2. So our p is equal to x plus minus, this is the same as the square root of 4x squared minus 1. Square root x squared minus 1, the square root of this as well. All this divided by 2. Root 4 is the same as 2, so this 2 cancels with that 2, so that we have our p being equal to x plus minus the square root of x squared minus 1. But we'd let our exponential y be equal to p, so replacing back with exponential y, so we have this being equal to exponential y. We introduce logs to both sides to solve. So I have ln exponential y is equal to ln x plus minus the square root of x squared minus 1. Using the power law of logarithms, I can be able to write this as y ln e. Ln e is 1, so we just have this as ln x plus minus the square root of x squared minus 1, which is the log form of cos hyperbolic inverse of y. Okay, let's take up another example. How do we evaluate the tan hyperbolic inverse of x? So the procedure is the same. Let this be equal to y, then bringing tan inverse to the other side, it will be tan hyperbolic y. So I will have x is equal to tan hyperbolic y. Then x is equal to the exponential form of tan hyperbolic y is exponential y minus exponential minus y, all this divided by exponential y plus exponential minus y. Then cross multiply and simplify where necessary. So this multiplying with x, I have x exponential y plus x exponential minus y is equal to exponential y minus exponential minus y. Okay, so let's put like terms together and try and see if you can be able to simplify this. So putting this and this together, or let's see. So I have x exponential y minus exponential y is equal to, so bringing this to the other side of the equation, I'll have minus x exponential minus y minus exponential minus y. Okay, so this factoring out exponential y, here I will have x minus 1. And then on this other side, factoring out exponential minus y, I will have minus x minus 1. Okay, I can rewrite this like this. I have exponential y into x minus 1 is equal to 1 over exponential y minus x minus 1. So multiply by exponential y on both sides of the equation. So I'll have exponential 2y, x minus 1 is equal to minus x minus 1. So divide by x minus 1 on both sides. So this will give me exponential 2y is equal to minus x minus 1 over x minus 1. Okay, so in order for us to solve this, we introduce ln to both sides of the equation. So we'll have this as ln exponential 2y is equal to ln minus x minus 1 over x minus 1. Now, we know that we cannot be able to get the log of a negative number. And when this is minus and this is minus, chances are very high that this is going to give us a negative number. So we can rewrite this in a better way. So first of all, solve this. We have 2y ln e is 1 is equal to ln. This is what I'm going to do. I'm going to take out the negative. So I remain with x plus 1, all this divided by, if I take out the negative on this lower side, I will remain with minus x plus 1. So the negative and the negative cancels, so that I have my 2y is now equal to ln x plus 1 over minus x plus 1. Okay, so divide by 2 on both sides. So I have y is equal to a half ln. I can write this as 1 plus x over 1 minus x. And this gives me the log form of tan hyperbolic inverse of y. Okay, next, let's look at the log form of sec hyperbolic inverse of x. So let this be equal to some y. Then following the same procedure, we have x is equal to sec y. Then x is equal to, so we write the exponential form of sec hyperbolic. So sec hyperbolic is basically the same as 1 over cos hyperbolic. So it's just the reciprocal. So we have 2 over exponential y plus exponential minus y. Cross multiplying that, we have plus x exponential minus y is equal to 2. Then can be able to rewrite this nicely so that I have this as exponential y is equal to 2, then multiply all through by exponential y. So I have x exponential 2y plus x is equal to 2 exponential y. This forms a quadratic equation. So rearranging it nicely so that you can be able to see, this is x exponential 2y minus 2 exponential y plus x is equal to 0. So let the exponential y be equal to some p. So this gives xp squared minus 2p plus x is equal to 0. So having a general formula for a quadratic equation, what is our ABC? So our A is the coefficient of p squared, which is x. Our B is the coefficient of p, which is minus 2, and our C in this case is equal to x. So using the quadratic formula to solve for p, we will have minus b, that is minus 2, plus minus the square root of b squared, so that is minus 2 squared, minus 4 times a, our a is x, so let me write it this way, times our c is x as well. All this is divided by 2 times a, and our a is x as well. So simplifying this, what do we get to be the value of our p? So we'll have our p is equal to 2 plus minus. Now inside the square root sign, we have 4 minus 4x squared, all this divided by 2x. So p is equal to 2 over 2x. Now we can be able to factor out the 4. It will give us root 4, which is the same as plus minus 2 over 2x. And then inside the square root sign, if you factored out 4, we will remain with 1 minus x squared. So remember, p is exponential y. So writing back exponential y is equal to, these 2's will cancel out, 1 over x plus minus 1 over x, the square root of 1 minus x squared. Introduce logs to both sides of the equation, and so introducing logs to both sides, this side will simplify to just y, because ln is 1 is equal to, so if we introduce ln here and ln on this other side as well. So this other side will be ln 1 over x plus minus the square root of 1 minus x squared over x. And that is the log form of sec hyperbolic inverse of x. Okay, fine. In a similar manner, we can evaluate cosec hyperbolic inverse of x. So let this be equal to y. So this gives me x is equal to cosec y. Then writing cosec hyperbolic is basically the same as 1 over sine hyperbolic. So writing it in its exponential form, it's the same as 2 over exponential y minus exponential minus y. Cross multiplying this, we have x exponential y minus x exponential minus y is equal to 2. Okay, so I can write this as x exponential y minus x over exponential y. If you bring this up, the power will be positive, is equal to 2. Then multiply all throughout by exponential y. So multiplying throughout the equation by exponential y, we'll have x exponential 2y minus x is equal to 2 exponential y. This forms a quadratic equation. If we rearrange, we have x exponential 2y minus 2 exponential y minus x is equal to 0. So writing the standard quadratic equation besides it, ax squared plus bx plus c is equal to 0. Then you can be able to identify the coefficients. So we will have the coefficient for our x squared, which in our case here is exponential 2y. The coefficient a is x, the coefficient b is minus 2, and the coefficient c, the constant, is minus x. So replacing into our quadratic formula, we have our exponential y will be equal to minus 2. plus minus the square root of minus b squared. So that is minus 2 squared minus 4 times x times x again, or times minus x actually, because the value of c is minus x. All this divided by 2 times a, and our a in this case is x. Okay, so this simplifies to exponential y is equal to 2 plus minus. This will give us the square root of 4 squared minus will give us plus 4x squared, all this divided by 2x. So divide by 2x here, divide by 2x here. To solve this, we introduce ln to both sides, and we know this side we can be able to simplify it. So this is 4, not 4 squared, this is 4. Okay, so to solve this, this simplifies to exponential y is equal to 1 over x plus minus. If we factor out root 4, we will get 2. So 2 divided by 2 there. So inside the square root sign, we will remain with 1 plus x squared, all this divided by x. So introducing logs to both sides, we will have ln e exponential y, which will just translate to y is equal to ln 1 over x plus minus the square root of 1 plus x squared, all this divided by x. And this is the log form of inverse hyperbolic of cosec, or cosec hyperbolic inverse of x. Okay, finally, how do we get the log form of tan hyperbolic inverse? So given tan hyperbolic inverse of x is equal to, let's say some y, let's tan, oh sorry, we already did for tan. So what we're supposed to do is cot hyperbolic inverse. So cot hyperbolic inverse of x. So this will give us x is equal to cot hyperbolic of y. So x is equal to, writing this in its exponential form. So cot is basically the same as cos hyperbolic over sine hyperbolic. So this will be exponential y plus exponential minus y over exponential y minus exponential minus y. Cross multiply and simplify. We have x exponential y minus x exponential minus y is equal to exponential y plus exponential minus y. Okay, so I can bring like terms on the same side. So I have x exponential y minus exponential y is equal to x exponential minus y plus exponential minus y. Factor out what's common. So I have x minus 1 is equal to, what's common here is exponential minus y. I have x plus 1. So this gives us exponential y x minus 1 is equal to, I can write this as 1 over exponential y x plus 1. So multiplying both sides by exponential y. So on this side, I'll have exponential 2y x minus 1 is equal to x plus 1. So bringing this to the other side, I have exponential 2y is equal to x plus 1 over x minus 1. So introducing logs to both sides, I'll have ln exponential 2y is equal to ln x plus 1 over x minus 1. So using the power law of logarithm, this translates to 2y is equal to ln x plus 1 over x minus 1. So divide both sides by 2 so that we have our y is equal to a half ln x plus 1 over x minus 1. And basically, this is the log form of cot hyperbolic inverse of x. That's it, guys, for today's session.